June 2019, question number 3b. It says, triangle ABC with vertices A 1 1, B 1 4, and C 3 1 is shown in the diagram below. All right, so we can see that. Now, the first thing we're asked to do with this is we're asked to, or we're told, triangle ABC is mapped onto triangle LMN by reflecting in the x-axis followed by a reflection in the y-axis. So I, on the diagram, draw and label triangle LMN. All right. In an instance like this, I think the best thing to do is to literally do the two reflection. So we're asked first to reflect the triangle in the x-axis. So if we do that, this is going to become the new position of A. All right, and if we want, we could probably call that A prime. Because what is important, the final shape we have to label LMN, but this is not the final shape. And the principle here is that in a reflection, the object and the image are the same distance from the mirror line on either sides of the mirror line. So the mirror line being the x-axis, C is 1 unit from the mirror line. So C prime, the image, is also 1 unit from the mirror line. So this is C prime. That's the new position of C, C, C prime. B is 1, 2, 3, 4 units on the mirror line. The image B prime is the same distance but on the other side. 1, 2, 3, 4. This is the new position of B. This is B prime. I'm guessing we could draw that, but we don't have to because we're not asked to draw this triangle. So I'm guessing now the triangle we're asked to draw is triangle LMN, and that is the image after we reflect ABC in the x-axis followed by reflection in the y-axis. So let us reflect in A prime in the y-axis now. This would be the new position of A, and that is going to be L. So the mirror line now is the y-axis, and in a reflection, the object and image are the same distance from the mirror line on either side of the mirror line. B prime is 1 unit from the mirror line. The image, which is M, is also 1 unit from the mirror line, but on the other side. So this is M. C, the image of C is N. C is 1, 2, 3 units from the mirror line. The image N is 1, 2, 3 units from the mirror line, but on the other side. So this is the point N. All right, we're asked to draw this triangle, so I'm doing it by freehand. You should, whenever you do it, you should ensure that you use a ruler. So that's the first thing we're asked to do, to draw a triangle LMN, which is the image of triangle ABC after a reflection in the x-axis followed by reflection in the y-axis. All right, let's continue. So next, we're asked to describe fully a single transformation that maps triangle A, B, C onto triangle LMN. All right, so let's go back to that diagram. Let's go back to that diagram to see if we can determine what is that single transformation. Well, the first thing, if you remember from our theory, that two reflection in non-parallel lines is equal to rotation. So the single transformation that represents these two reflection is a rotation. Again, the principle says that if we reflect into or reflection into non-parallel lines is equivalent to a rotation. So I know the single transformation is a rotation. All right, but let us just see if we can determine what is the angle of the rotation. All right, here we can see that what A became L, and if O is the center of rotation, that angle AOL is 180 degrees. All right, so the single transformation is a rotation. It's a 180-degree rotation about the origin. All right, so let's write that. So now I can say that triangle ABC is mapped onto triangle LMN by a rotation of 180 degrees about the origin. Now, for 180-degree rotation, you do not have to state the direction, because 180 degrees clockwise or 180 degrees anti-clockwise takes you to the same what spot. All right. Triple I is asking us to state the 2 by 2 matrix, and this is only for 1 mark. State the 2 by 2 matrix for the transformation that maps triangle ABC onto triangle LMN. Alright, so for 1 mark is either you know it or you don't know it. There isn't anything much to work out. We could go back to the diagram and get some information from it. Alright, and then maybe that could help us. So let's just go back for the diagram for a second. Alright, so the first thing, let us see, we observe that C, which is 3, 1, C, which is 3, 1, became N, which is what? Became N, which is minus 3, minus 1. So what I'm observing is that for this transformation, the x and y coordinates remain in the same position, but their signs change. So minus 3 became minus 3, and 1 became minus 1. All right. Now the matrix that does that, the 2 by 2 matrix that does that to a point, is the matrix matrix minus 1, 0, 0, minus 1. This is the 2 by 2 matrix that does that. So that the point C, which is what? 3, 1, would become the point N, which is minus 3, minus 1. Alright, first of all, 1, 0, 0, 1 is the identity matrix. If we multiply the identity matrix by a point, the point remains the same. But if by putting a negative there and there, changing the positive ones to negative 1, what that will do is that the coordinates would remain in the same position, but their signs would change. All right, so this is the end of the question.